Good afternoon, and welcome to the NPS Archaeology Program Speaker Series for 2014. My name is Karen Mudar, and I'm an archaeologist in the Washington Archaeology Program Office. Today, we have three very interesting talks about park-related research and training that tie into our dedicated topic last fall, which was archaeological recordation and prospection. Steve Vore has directed numerous field training programs on archaeological prospection and recordation. I've not had the opportunity to attend, but I understand that it is excellent grounding. And his talk today will focus on the history of this program. Dawn Brindleson, a colleague of Steve's at the Midwest Archaeological Center, will be talking about research carried out to explore artifact distribution within Indiana Dunes National Lakeshore and the influence of dune history on the distribution of artifacts. And Philip Mink, a colleague at the University of Kentucky, is joining us to talk about some research that he carried out in Grand Canyon National Park. And these last two talks are nice examples of the use of different kinds of recordation technologies that are allowing archaeologists to expand the scale of their research potential. All of our speakers, both this week and next week, gave these talks earlier this year at the SAAs, and those of us who are not able to attend the meetings appreciate their cooperation in presenting their papers again. So Steve, thanks very much for talking with us today.
Good afternoon.
Let me get your slides set up for you.
I want to say that the paper itself is actually was a joint paper by myself and Lou Summers of Geoscan Research. He's been with us doing the workshop for a number of years now. Okay, so we're ready. The National Park Service's archaeological program has been instrumental in the development and application of geophysical techniques to archaeological investigations since their inception in the United States in the early 1960s. Since the initial application of these techniques, the archaeological community has seen dramatic changes in the way archaeological research is conducted and viewed by the larger segment of the nation's population. Federal legislation and increasing impact on the archaeological resources by development, visitation, and vandalism has made the management of archaeological resources a primary concern of the archaeological community. And wise management should incorporate non-invasive assessment of sites not threatened, evaluation of sites and areas to be ordered, and identification and recovery of information where the sites are to be destroyed. In all cases, any rapid, non-destructive technique for the evaluation of the sites that provides archaeological significant information becomes of paramount importance. The archaeologists in the National Park Service have realized the contribution that geophysical techniques can provide archaeological investigations of site-specific problems. While these techniques have not lent themselves to site discovery and identification, I should add this is changing rapidly at the present time, they are powerful, effective tools for the acquisition of intra-site information. The National Park Service has been in the forefront of the nation's professional community in the development and application of geophysical techniques to archaeological problems, as well as training of these techniques. Modern application of geophysical techniques to archaeological investigations really developed after World War II. While there were recorded attempts using geophysical techniques, basically sound waves by Lieutenant General Augustus Pitt Rivers in the 1890s at Hanley Down in Dorchester, England, and then there was a 1938 equal potential survey by Mark Malafi at Williamsburg, Virginia. The first real major application of geophysical techniques to archaeological prospection occurred in 1946 when Richard Atkinson used a Megger earth tester for a resistivity survey at the site on Dorchester-on-Thames in England. Since then, transistor technology in the 1950s led to the use of more compact and reliable resistivity systems. In 1956, Anthony Clark and John Martin developed the Martin-Clark resistivity system with archaeology in mind. And in 1958, Martin Atkin and Edward Hall conducted the first magnetic survey along a road construction project in a Romano British pottery kiln near Peterborough in Northamptonshire in England. In the United States, the first application of geophysical techniques was in 1958 when Dr. Glenn Beck, the director of archaeology at the Indiana Historical Society, tested a relative resistivity instrument at the Angel site in southwestern Indiana. Although not conclusive, the results of the resistivity survey did suggest the potential application of the technique to archaeological investigations. Following the successful application of the proton magnetometer in England, Black tested the use of a proton magnetometer at the Angel site. Although this test also indicated the potential application for magnetic survey techniques in American archaeology, the equipment was not suited for the specific application at the Angel site. Further development of the LSAC magnetometer in England, designed for archaeological applications, resulted in its purchase by the Indiana Historical Society in 1960. This led to the first formal magnetometer survey of the Angel site in 1961 by Glenn Beck and Richard Johnson, a research associate at the Angel Mounds Archaeological Research Station. In August, Richard Johnson conducted the first geophysical investigations on a national park. Trials were conducted at two ruins on Weatherall Mesa in Mesa Verde National Park. Again, the results were less than satisfactory, but Johnson reserved judgment on the technique until the excavational findings are known and can provide some basis for comparative analysis. And this statement is still as relevant today as it was in 1961. There's still a need for comparison of the geophysical data with the excavated archaeological features, and a closer interaction of the geophysical investigator with the archaeologist is extremely important in successful interpretation of the geophysical data. In England, the commercial version of the Martin Clark resistivity instrument was made available in 1960. At the same time, John Aldred of the Oxford Laboratory also developed a fluxgate gradiometer for archaeological investigations. John Muskie established the geophysical section of the Ancient Monuments Laboratory in 1967, and during the early years of the geophysical section, it consisted of one person, Anthony Clark. And as Clark put it, he had a strong incentive to use equipment operable by one person. In 1968, Clark had the opportunity to experiment with a number of new techniques at Vernon Fleming. The 1960s also saw the development of the Bradford University School of Archaeological Sciences and the work of Arnold Aspinall and his students. In the United States during the 1960s, the development of geophysical applications to archaeological investigations was centered at the Museum of Applied Science Center for Archaeology at the University of Pennsylvania in the United States. Doctors Elizabeth Ralph and Foley Trainee conducted numerous geophysical survey techniques throughout the States and around the world during this decade. They also published a number of articles on the application of the techniques to archaeology. In 1969, the National Park Service initiated a remote sensing project which had a major effect on the application of geophysical techniques to non-destructive archaeology. This program was conducted with remote sensing techniques, was concerned with remote sensing techniques and applications to the discovery, exploration, investigation, recording, evaluation, monitoring, and management of cultural resources. Although geophysical techniques did not play a major role in the various remote sensing techniques utilized during the project, its importance to future archaeological geophysical investigations was identified. Important partnerships between the National Park Service and geophysical investigators were also established during this period. In addition, the project supplied archaeologists and cultural resource managers with a handbook and a series of 10 supplements, of which 4 of the supplements refer to the use of geophysical techniques. One early aspect of the project began with the establishment of the partnership between the National Park Service and the University of New Mexico and the creation of the Chaco Center in 1971 to conduct multidisciplinary research in remote sensing at Chaco Canyon National Monument. In 1973, a proton magnetometer was used to conduct a magnetic survey over a portion of the Chetro-Kelt field. Geophysical investigations at Chaco were also the first to use ground-penetrating radar for archaeological exploration. GPR surveys between 1974 and 1976 were carried out at Pueblo Bonito, Hongo Pavi, Pueblo Alto, and several backfilled pit houses. The 3-year geophysical or GPR survey also involved Dr. Elizabeth Ralph and a technician, Bruce Bevan, from the Museum of Applied Science Center for Archaeology. It should be noted that Bruce was basically the technician to make sure that the radar system was operating correctly through their surveys. He will become a major contributor to the field of geophysical archaeology over the next couple of decades. During the 1970s, another partnership between the National Park Service and the University of Nebraska was also developed. In 1974, staff members from the Midwest Archaeological Center worked with Dr. John Weymouth of the Department of Physics and Astronomy at the university on a project to evaluate the use of total field magnetic surveying as a detection technique on village sites along the Missouri River. Working with Robert Nickel and others of the MWAC staff archaeologists, Dr. Weymouth conducted a magnetic survey of portions of the Wolf Bay site using a stationary reference proton magnetometer and a roving magnetometer. Since the magnetometers were not linked, it was necessary to fire both magnetometers simultaneously on the command of one operator and then record the values on a pad of paper. Dr. Weymouth concluded that the magnetic survey could, under favorable conditions, provide data on the location of house floors, fire basins, and cache pits. Dr. Weymouth and Robert Nickel continued their collaboration on numerous National Park Service projects over the 3 decades since this initial effort at the Wolf Bay site in South Dakota. In England, under Arnold Aspinall's leadership from the 1970s through his retirement in 1990, the Bradford brand of archaeological science was to take the lead in archaeological prospection. Turning out students such as John Lyman and Roger Walker, Bradford was to play a major role in the development of geophysical instrumentation and techniques in England, as well as impacting archaeological methodology throughout the world. In 1970, John's dissertation on geophysical prospection techniques for archaeology included a section on the twin probe resistance array. In 1984, Roger Walker, another graduate, established Geoscan Research. Through the years, the company under his direction has produced resistance meters and probe arrays along with the flux gate radiometers, and these were designed specifically for archaeological investigations. They have become the industry standards throughout the world. Other students from Bradford through the 1970s, 80s, and 90s also continued the development of other geophysical instruments and techniques for archaeological applications. During the remaining part of the 1970s and throughout the 1980s, Drs. Bevan and Weymouth formed the core of the National Park Service's geophysical investigations. Working mainly through MWAC, Dr. Weymouth conducted geophysical projects at numerous prehistoric and historic sites in the Midwest and in the Southeast, along with Robert Nickel, who conducted the field acquisition phase of the project. One major project was the geophysical investigations at the Knife River Indian Village's National Historic Site in North Dakota. This multiple-year project from 1976 to 1981 looked at the main village sites as well as several smaller sites within the park. It also demonstrated the effectiveness of magnetic surveying on a large scale in North America. And I should add that we recently had the opportunity to go back and re-look at some of the major village sites and collect the data at a sample density that is more amenable to the modern techniques. And we're in the process of putting that report together. One thing I can say is that even though the magnetic survey done by John was at a larger scale, the data still indicates the presence in both sets of the various features he first noticed. The University of Nebraska and the MWAC team also conducted smaller magnetic surveys at several parks in the Midwest and Southeast regions over the years. Dr. Weymouth has also presented numerous papers on at archaeological, geophysical, and geological conferences. He's participated in archaeological field schools and taught archaeological-oriented geophysical methods courses at the university during the following couple of decades. And I should add, we all sorely miss his passing. The majority of these projects were total field magnetic surveys, although the team did do a few limited resistivity surveys. In the eastern United States, Dr. Bevan, working with the Mid-Atlantic and North Atlantic regions of the National Park Service, conducted numerous multi-instrument surveys at Revolutionary and Civil War battlefields, historic farmsteads, historic homes, plantations, and early Euro-American settlements. He also conducted a limited number of surveys at Midwestern parks where he conducted ground-penetrating radar tests at mounds, Native American burials, and a boyhood home of President Herbert Hoover. Multiple year projects by Dr. Bevan were conducted at several parks where he used multiple geophysical techniques, including ground-penetrating radar, magnetometers, resistivity meters, conductivity meters, and other types of geophysical instruments. Although Bevan and Weymouth conducted the majority of the geophysical investigations in the National Park Service in the 1970s and 80s, other NPS archaeologists also conducted their own surveys or contracted with others for geophysical investigations. A grass fire in 1983 at the Custer Battlefield National Monument, now the Little Bighorn Battlefield in Montana, resulted in the development and application of metal detectors to battlefield reconnaissance surveys. In 1984 and 1985, MWAC staff and volunteers established the survey methodology that has been a standard geophysical investigative technique for the study of troop movements during a battle, the investigation of related campsites, the investigation of historic sites, and the forensic investigations of modern-day atrocities and crime scenes. Although metal detectors had been used on archaeological sites as early as the 1950s in the United States, including the use of metal detectors at Little Bighorn in 1958, there were no systematic applications of this technique until the 1983 investigations at the Little Bighorn battle site between the U.S. Cavalry and the Native Americans on June 25th and 26th, 1876. The MWAC archaeologists continued to develop these techniques throughout the remaining years in the 1980s. A chance meeting in 1988 of 4 geophysicists and geologists from Denver, including Clark Davenport, Don Heimer, John Linderman, and John Gilmore, and myself at Fort Laramie National Historic Site, set the stage for the National Park Service geophysical workshops in the 1990s. The folks from Denver visited the park to demonstrate the application of geophysical techniques to archaeological investigations. And I was basically there just to monitor their activities. In 1989, I got a permanent position with the Interagency Archaeological Services in the Rocky Mountain Regional Office in Denver. And during the next winter and spring, Clark and I discussed the possibility of holding a training course on geophysical techniques for federal and state archaeologists in the Denver area. And with the assistance of the Colorado State Historical Preservation Office, we selected the 12-Mile House in the Cherry Creek State Recreation Area just on the south side of Denver in 1990. The training was in the use of magnetometers, conductivity meters, and ground-penetrating radar. These were provided by the geophysical staffs from Ebasco Services and Geo-Recovery. In 1991, the National Park Service received funds from Congress to provide training in cultural resources. This cultural resource training initiative provided funds for numerous projects during the 1990s, including several remote sensing geophysical workshops sponsored by the Interagency Archaeological Services, and ones in basic aerial photographic interpretation and the use of low remote control planes for low altitude, large scale aerial reconnaissance. To date, we've completed 24 years of training in 19 different places across the country. 10 of the workshops have been held on national parks, 3 on national historic sites, 2 along national historic trails, 1 at a NPS Archaeological Center, 6 at state parks, and 2 at the Army Mechanized Training Facility at Pinyon Canyon Maneuver Site. The workshops have provided both lectures on the use of the techniques and as well as hands-on applications. The instructors for the workshop are some of the leading practitioners of geophysical applications in archaeology, environmental geophysics, and archaeological photography. To date, we've had instructors from around the United States as well as from England, the Netherlands, Greece, Turkey, and Russia. The participants for the workshop have collaborated with the instructors on projects, have conducted their own projects, and have integrated training into their own university programs. Again, we've had, most of the participants are from the United States, but we've had several participants from Canada and Mexico. We've also had folks from India, China, Spain, Israel, Sweden. I hope I didn't leave any of the other countries out, but it's become more or less an international workshop with both instructors and participants from all over the world. The training initiative also funded a workshop at Colonial National Historic Park under the instruction of Dr. Bruce Bevan. I should add that when we first started the workshop down at Pinyon Canyon in 1991, Mark Davenport, who I've been working with, indicated that he wasn't going to be able to attend, but he decided he would find somebody that would be able to do or talk about archaeological geophysical methods. And that was when I first met Bruce Bevan. And he's been at the workshop for 18 years till he got, as he put it, tired or bored of the workshop. I think later I found out that the real reason he had found him a future wife. Also, during the early 1990s, the National Park Service saw the creation of the agency's National Center for Preservation Technology and Training. After nearly 2 decades of effort to establish the center, Congress approved the NCPTT and the 1992 amendments of the National Historic Preservation Act. The NCPTT grant program was designed to meet the needs outlined in the 1988 Office of Technology Assessment report to Congress by developing and distributing skills and technologies that enhance the preservation, conservation, and interpretation of prehistoric and historic resources throughout the nation. A number of the geophysical projects have been funded, including the development of equipment and techniques, distribution of the information through the internet, workshops on techniques, and archaeological field schools. Well, are we there yet? This expression is commonly heard on long trips by us who have children. It has been in place. It also has a place in the development and acceptance of application of geophysical techniques to archaeological investigations. The National Park Service, serving as the lead cultural resource agency under the Secretary of Interior, has been involved in the development of these techniques since the late 1950s. Some of the first uses of the techniques in the States have been on projects in the nation's national parks. The application of the geophysical techniques to archaeology in the parks has also been fundamental in the development of these techniques, as well as their acceptance in the nation's professional archaeological community. However, there has been no national program dedicated to the advancement of these techniques as found in England. There's also a lack of any systematic application of these techniques. Most of the agency's geophysical activities have resulted from individual initiative at the field level, both in parks and at the regional offices. The techniques have been proven to provide significant information on the subsurface archaeological deposits in an effective, cost-efficient manner. Several recent articles have highlighted the use of geophysical techniques, their benefits, the lack of integration into the archaeological toolkit. They have also identified the lack of undergraduate and graduate training in these techniques in the United States. While there have been several articles on geophysical techniques over the years, publications on specific techniques like Larry Conyers and Dean Goodman's publication for ground penetrating radar have been severely lacking until recently, and now there are several books out that covering a variety of techniques. While the National Park Service's National Centers provide training on various cultural resource laws and archaeological management of resources, there has been little guidance on the application of these geophysical techniques to the evaluation of archaeological resources. And this is one of the areas where, again, England is way ahead of us. They have developed guidelines in the 1990s, which they apply to their projects. Now we're going to get kind of the part of the section where Lou also contributed. The person you see on the right here is Tony Clark, and on the left is, or to reverse that, is Arnold Aspinall, and they were the major leaders in the development of magnetic and resistance surveys in England. And Lou just wanted everybody to, or he just wanted to acknowledge their contributions. Just to get a feel for these developments, this is Tony Clark and others struggling with an early probe resistance system, and you can notice the earphones on Clark's head. And then in the other picture, you have Tony with Una with the early fluxgate gradiometer. Today, most of the flux gates are operated by one person rather than two. Another variation of an early gradiometer by Philpott included an analog data logger and display. And then finally, we have a fully integrated magnetometer with data averaging and data logging by Roger Walker, showing one of the geoscanning instruments and using two instruments for collecting two lines at one time. While there's been a few problems along the way, as Lou put it, they've managed to wrestle the alligators to the ground. This is one of the current generation of England's archaeological geophysics investigators. This was taken at their Fort Cumberland graduation on developing landscape scale magnetics, or probe resistance, and GPR systems. This is Roger Walker next to Andrew David. And Andrew is the one who's developed their guidelines for England on doing geophysical investigations. On the other side are the Linford brothers, Neil and Paul, then Alistair Barnett, Andy Payne, and Lou Summers in the middle. Just to give you an idea what some of the early instruments look like, this top band is actually part of the magnetometer system for the Indiana Historical Society, their ALSAC magnetometer. But most of the control unit stuff is in here. The sensor is out in the field. The bottom picture shows Dr. Weymouth conducting a proton magnetometer survey at the Knife River Indian villages in the late 1970s. So this has gone on. It's really in 1992 where everything changes for the, this is the second year of the National Park Service Workshop. Prior to the start of the workshop, I got an extremely long letter from English Heritage explaining to me why I needed to have this person attend, and that was Lou Summers. In accepting the application and his attendance, he mentioned to me that he had a couple of pieces of equipment that he'd like to bring. And since we were using the geophysical instruments from Ebasco Services and GeoRecovery, we immediately accepted his kind offer. And the picture you see here in the center is Clark Davenport. This is John Weymouth on the side and Lou Summers on the other side. And this is just some views of various geophysical equipment, some of the different ones. And at the top corners are the proton magnetometer, or the cesium magnetometers. This one here is a Jim Overhauser effect magnetometer with a GPS antenna attached to it. Several pictures of the GeoScan magnetometers and the use of the dual system by GeoScan. More recent developments in England and in Germany have been the development of the Barlington dual radiometer system here with Jeff Barlington holding it, and then Forrester magnetometer produced out of Germany. And we've been real lucky in the fact that a lot of the manufacturers are willing to come to the workshop, work with people, and we get the benefit of seeing the new equipment, but they also get an idea of what archaeology is really about and how we use their equipment and what their equipment needs to be able to do for us. Again, here's some of the resistance systems. This is the twin probe array system by GeoScan, another system by out of England, and then some of the later work with GeoScan using a multi-sensor platform. The wheels on here actually have the sensors, and they're being collected in the center. You can also mount a flux gate gradiometer on the instrument so you can collect two different types of data sets at once. Here's some views of different ground-penetrating radar systems. In the upper picture on the corner is Dean Goodman and Larry Conyers looking at the GSSI GPR cart system. Another cart system manufactured by Sensors and Software out of Canada. You can see the incorporation of a GPS antenna on the ground-penetrating radar. Another Sensors and Software style radar. This time, this is one that, instead of being on a cart system, which is a newer way of collecting data, this one here, you'd have to pull along your survey line. Again, collecting data with the GPR cart system. And then the final picture is two Mala GPR systems racing down the path at Fort Frederica, this workshop. Just some more equipment and instructors and students at the workshop. Here's Bruce Bevan with a Schonstadt pipe locator. Students here are laying out a multi-probe resistivity system and taking readings at between each one of the probes. Here we have Douglas Scott giving discussion on using metal detectors. Renita Dalen using the downhole probe designed for magnetic susceptibility sampling, which she designed through funding from NCPTT. Another use of the Barlington magnetic susceptibility field coil out in the field with Garrett Burks and one of the students collecting data on the GSSI electromagnetic profiler down at Fort Brown. Vore Clay discussing the use of electromagnetic conductivity meter with participants at one of the workshops. Renita Dalen actually beta testing Geonics new EM38 Mark II, and finally a Geometrics ohm mapper capacity coupled resistivity system. So to where everything changed at Brown Sheep Camp on the Indian Canyon Maneuver site, I mentioned Dr. Weymouth, Clark Davenport, and Lou Summers. We also have Lou Summers with Bruce Bevan and John Weymouth, and another one where they're discussing what's going on. Well, both sides of the pond, as Lou put it, have come a long way in their own archaeological prospection endeavors. Joint communications and activities such as these provide us with increasing potential for cooperation. Again, saying that, the road to the future still has its ups and downs. All right, thank you. Are there any questions? Any comments?
Well, thanks for a great talk, Steve.
You're welcome.
This is Karen. I have a couple of comments and a couple of questions. First of all, I had not realized how many years you have been putting on these training workshops.
It's a big secret. I've kept it that way.
Wow, I guess. Are you going to have one next year?
Yes, we are. We're going to have one down in southeastern Kansas by Wichita. It's going to be looking at some of the they're Tobias complex sites, but they're protohistoric Wichita village sites. We'll be working with Wichita State and with the state archaeologists in Kansas and doing the workshop. We're tentatively scheduling the dates, and this is going to be hard for some people. It's going to start on Memorial Day and go through that week.
Oh.
The bad thing is we couldn't get rooms down anywhere close due to graduations at the various universities in the area.
Oh, I can imagine.
It's a little later than when I usually do it. Hopefully we'll catch people before they actually get back out in the field. But it's one of those kind of hit or miss things that we always have problems with scheduling it, a year or so in advance. But it should be a great workshop. It's going to be looking at some really interesting village sites.
Well, I hope you get lots of attendance. Do you offer scholarships?
Not necessarily scholarships. We have been known to waive student fees. You have to understand that the money raised for this through the registration is basically designed to pay for the instructors' travel and their participation in the workshop.
Uh-huh.
And I should add that all of the instructors, and I have, and it varies from year to year, from 10 to 15 instructors, all volunteer their time to the workshop. They've been very dedicated to this. And we certainly have, we've come a long way since when we started this in 1991. The techniques have improved, the type of equipment that's out there, and, even computers have come a long ways from even then.
Oh, yeah.
One of the things, and I just happened to watch this on the, I don't know whether it was on the Public Education Channel or whether it's on National Geographic or whatever, but they had a show on Stonehenge, and I think it was something like Stonehenge Revealed, but it's showing the kind of the direction of geophysical investigations to the larger landscape, where they were looking at the whole region around there, doing large-scale surveys of very large areas. And now we're seeing multiple sensor arrays in ground-penetrating radar, in magnetometers. Resistance still has multiple arrays, but they are lag behind because of the their pokiness or slowness, as one of the instructors, Chris Lockyer, would put. But the area is opening up extremely fast, especially with radar. There's multi-channel, multi-unit systems now where they're putting 8 to 10 sensor arrays, driving them around on a site and using GPS to keep track of where they're at.
Wow, that's really impressive. I was glad that you spoke about Dr. Bevan's contributions. When I interviewed Julie Steele at Petersburg, she said that she had been trained by Dr. Bevan as well.
Mm-hmm.
So he's had quite an influence on Park Service archaeologists. Does anybody else have any questions or comments for Steve? I'm sorry I cut you off, Steve. Did you want to say something else?
I was going to say both Bruce Bevan and John Weymouth were really the main founders for a lot of the work that's been done in the United States, or certainly took what Glenn Black and the folks from University of Pennsylvania started. Their contributions, we wouldn't be where we're at today without them. And Lou would probably say the same thing about Tony Clark and Arnold Aspinall and others in the UK.
Yes, they've been really a lot of very important contributions. Thanks very much, Steve.